Scientists are stumbling upon revelations that feel like the universe is pulling the rug out from under us. The newest data is so startling that even long-respected researchers are whispering that a major shift may be approaching, something our current theories are nowhere near equipped to explain. In a recent conversation, Andrei Kutso, a postdoctoral scientist at Lawrence Berkeley National Lab, admitted, with a mix of awe and disbelief, "We're here to let the universe show us its rules." And it might be hinting that the story is far more tangled than we assumed. With every new observation, the Webb telescope keeps peeling back layers of cosmic mystery, surprising researchers who thought they had at least the basics figured out. Not long ago, teams studied a staggering 30,000 infant galaxies captured by Webb and uncovered peculiar traits that clash with everything we thought we knew about how the early universe evolved. Yet the surprises didn't stop there. Webb then examined another 20,000 primordial galaxies, and the results left scientists staring at the data in disbelief. This enormous investigation hints that the long-held idea of the universe expanding might not be the whole truth, or might even be misleading us entirely. The findings have left many experts wondering, almost breathlessly, if we're standing at the edge of a discovery powerful enough to rewrite the origin story of the cosmos. Is it possible that the Big Bang, the foundation of modern cosmology, isn't the final answer after all? So what exactly did Webb uncover? And why are researchers suddenly questioning the very birth of everything? A recent publication in Nature Astronomy described a breathtaking revelation. Webb has spotted an enormous, fully formed galaxy from the universe's earliest chapter. This ancient titan, nicknamed the Big Wheel, sent its light sailing through space for more than 12 billion years before it reached Webb's mirrors. It existed when the cosmos was a mere fraction of its current age, roughly during the universe's first 2 billion years. Its very presence shatters expectations. Detailed images show that the Big Wheel rivals today's gigantic superspiral galaxies in both size and rotation, behaviors far too advanced for its era according to existing models. It's 3 times larger than any galaxy scientists would expect to see from that young epoch, making it one of the heaviest and most mature structures ever seen at such an early time. Standard cosmological theory insists that galaxies from this period should resemble messy, undeveloped clumps, small, chaotic, and lacking organized structure. But the Big Wheel refuses to fit the script. Instead, it appears as a fully realized giant, an elegant outlier in an era where nothing this refined should exist. With this first telling piece of the jigsaw, new questions emerge. Setting aside the stunning sprawl of the Big Wheel, how is such a heavy galaxy fit into existence at this time? Cosmic simulations struggle to account for its mass, indicating that our models need rethinking.
And astonishingly, it's far from alone. Webb has uncovered several massive, well-shaped galaxies from these primordial years, yet none of them compared to this one. So far, the Big Wheel stands unmatched as the largest, most astonishingly developed galaxy known from the universe's childhood. And just when researchers thought the surprises had peaked, Webb revealed even stranger phenomena hiding in the earliest darkness of cosmic history. Fresh revelations from the Webb telescope have shaken scientists once again, this time pointing to something unsettling about dark energy itself. Researchers are beginning to suspect that this strange, invisible force responsible for pushing galaxies apart isn't as steady as we once believed. Instead, it may be shifting in ways that pull at the very fabric of space and time. Some astronomers quietly admit that they might be standing on the threshold of the most profound breakthrough in decades, one that could overturn long-trusted theories. What makes this early evidence even more startling is that it clashes with the framework partly laid down by Albert Einstein. While the data still needs rigorous confirmation, even cautious veterans like Professor Ofer Lahav of University College London are finding it difficult to ignore the growing weight of the observations. The discovery of dark energy back in 1998 was shocking enough. Before that moment, scientists assumed the cosmos would slow its outward rush after the Big Bang, its speed gradually dampened by gravity. But when American and Australian teams revealed that the universe was actually accelerating, astronomers were stunned. Unable to explain the cause, they labeled it dark energy, a name that admitted just how little we understood. Even though its true nature remains a mystery, researchers can still track dark energy's influence by watching how galaxies drift apart over different epochs. When specialists working with the Dark Energy Spectroscopic Instrument noticed hints last year that the force seemed to vary with time, many dismissed it as statistical noise. Yet after another year of painstaking measurements, the team has grown increasingly convinced that something genuinely odd is happening. Professor Sheshadri Nadafar from the University of Portsmouth explained that a battery of new tests has strengthened their confidence that the effect isn't the result of overlooked errors. Around the same time, Webb's deep field observations revealed that dark energy behaved differently in the universe's youth than it does today. Nobel laureate Adam Rees, who led the analysis, described the results as deeply puzzling. Depending on the method used, the universe's expansion rate appears to change. When astronomers look at the cosmic microwave background, the oldest light we can see, they get one value. But when they rely on predictions from the standard cosmological model, the result is completely different. This stubborn disagreement is known as the Hubble tension. This widening divide between measured expansion and theoretical expectations hints that our cosmic blueprint might need rewriting. For years, scientists worked under the assumption that dark energy pushed outward with the same strength everywhere and always. That belief allowed them to estimate the universe's age and reconstruct how it transformed over billions of years. But mounting evidence now suggests that dark energy may not be the calm, constant force we once imagined. Its behavior may be far stranger and far more dynamic than anyone expected. Instead of behaving like a steady, unwavering force, dark energy now appears to act in ways that undermine long-standing beliefs. If these findings hold up, they could topple the idea that every corner of the cosmos shares the same clock. Because a shift in the pace of expansion would mean that different regions have aged along distinct timelines. Some parts of the universe may have raced ahead, expanding earlier or faster, while others lagged behind, changing the way we interpret their true age. To make sense of this growing web of contradictions, researchers have introduced a bold new framework known as time-step cosmology. This model emphasizes how enormous cosmic voids and dense structures might influence the flow of time itself. In this view, the universe isn't being pushed apart by a mysterious force at all. What we perceive as accelerating expansion could simply be the result of time passing at different rates in different places. According to this idea, time slows down in areas packed with matter. For example, an atomic clock buried inside a galaxy would tick significantly more slowly, perhaps a third slower, than the same clock floating inside a vast, nearly empty void. Now, stretch that difference over the full lifetime of the cosmos. Although we often quote the universe's age is 13.8 billion years, that number only holds in regions with typical matter density. In the deep emptiness of cosmic voids, where time flows more quickly, far more years could have unfolded. That means there is no single universal age for the cosmos. Instead, the age of the universe changes depending on your location.
Vast voids could be older simply because time has raced ahead there, while denser regions have experienced a slower cosmic clock. And it gets even stranger. Because so much more time has passed in those emptier regions, they've stretched far more dramatically. In other words, the expansion isn't uniform. Voids swell faster than the regions packed with galaxies. If you observe a galaxy behind a wide void, it will appear to be racing away far faster than one on the near side, simply because the space inside that void has expanded more rapidly.
Now, scale that effect to the entire universe. Over billions of years, voids grow disproportionately larger because they expand more quickly. From our vantage point, this patchwork of faster-growing regions makes it look like the whole cosmos is accelerating. Under timescape cosmology, that illusion eliminates the need for dark energy altogether. The differential ticking of time itself could explain what we see. Back in 2017, astronomers at the University of Canterbury in New Zealand tested this model against observations and found that it matched the data slightly better than the standard lambda cold dark matter. Then, in a striking new Webb telescope survey of 30,000 galaxies, researchers noticed something even more puzzling. Most of these galaxies were spinning the same way. This is profoundly odd because if the universe began as a chaotic, turbulent explosion, as the Big Bang suggests, galaxies should rotate in random directions. Instead, this surprising alignment hints that the cosmos might have begun with a primordial spin, an idea completely absent from mainstream theories. Taking this even further, a few scientists are revisiting a daring possibility that our universe may have been born inside a black hole. This concept, part of the black hole universe hypothesis, suggests that our cosmos could actually be the interior of an enormous black hole, its rotation imprinting order on everything inside. Each new discovery deepens the mystery and reminds us how much we still have to learn about the nature of existence itself. And with that, we've reached the end of this journey. If these ideas sparked your curiosity or left you with new questions, feel free to share your thoughts. We love hearing from you. Thanks for being here with us.